Hello and welcome to this Edexcel Further Math Statistics 1 video, Type 1 and Type 2 errors definitions. So the background of Type 1 and Type 2 errors involves two important points. One, that when a statistical test is carried out, it's based on only one sample from a population, and there are lots of different samples that could potentially be collected. And secondly, any conclusion to a statistical test is never definite, but simply based on likelihood. A type 1 error is defined as incorrectly rejecting the null hypothesis, and the probability of a type 1 error is equal to alpha, the significance level of the test. A type 2 error is defined as incorrectly accepting the null hypothesis, and the probability of a type 2 error is denoted with beta. And a type 1 error can be regarded as a false positive, and a type 2 error as a false negative. If you'd like to pause the video at this point and just read through the example and decide what the null and the alternative hypotheses are for this test. And hopefully you can spot in the question that we are talking about means, and you've already met hypothesis tests for an unknown population mean, and we're looking at the mean time with the new treatment being the same as for the current treatment. So mu equals theta, there's no difference to what it was before, or the alternative, which is going to be mu is less than theta, the mean time to cure the disease with the new treatment is faster. So we have our null and alternative hypotheses. What are the possible outcomes when we carry out this sort of test? So in reality, our null hypothesis is either actually true or it's false, and when we carry out the test, our conclusion may either reject the null hypothesis, so we're saying the null hypothesis is false, or we may accept the null hypothesis and conclude that the null hypothesis is true. And of course, if we accept a true null hypothesis, that's fine, and if we reject a false null hypothesis, that's fine. The errors come in when the null hypothesis is actually true but we ended up rejecting it, or the null hypothesis was false and we ended up accepting it. And it's worth pausing again and just thinking of the implications of making a type 1 or a type 2 error. So with a type 1 error, we'd reject a true null hypothesis. We'd bring in the new treatment thinking it's going to be faster. Everybody would believe that's going to be the case, but in fact it's not going to cure the skin disease any faster than the original treatment. On the other hand, with the type 2 error, the null hypothesis is false. The new treatment's actually faster, but we've accepted the null hypothesis, so we're not going to bring in the new treatment, so patients will have to wait longer using the existing treatment when the new treatment might actually have speeded up their cure. And either way, patients are going to be a bit disappointed. And there can be much more serious implications involved in making errors. For example, if we are carrying out a hypothesis test looking at diagnosing whether somebody is normal or whether they have a disease, it could be that the person is normal, H0 is true, but we reject that. We've got a freak result and we reject that, and therefore that person is going to get invasive treatment when they don't actually need it because they don't actually have the disease. The alternative to that is the patient actually does have the disease. H0 is false. They're not normal, they do have the disease, but we end up accepting H0, so we think they are fine, and those patients, because of the type 2 error being made, will be denied the treatment they may need. So how can a type 1 error occur? A hypothesis test has the probability of a type 1 error built into it because the probability of a type 1 error is equal to the significance level of a test. So how does that type 1 error happen? Well, type 1 errors will generally happen because an unusual or an unrepresentative sample will have been obtained for testing. So by chance a freak sample is obtained and the sample statistic falls in the critical region, so we reject the null hypothesis even though the new treatment isn't faster. And again with a type 2 error, how can a type 2 error happen? So a type 2 error very frequently occurs because of a small treatment effect, and that's something you might like to research. And in effect what it means is that there is a difference between the mean speed for cure for the two treatments, but the difference is really quite small, and therefore it's quite unlikely our sample will give us such an extreme result to lead to us actually rejecting the null hypothesis. And we'll have a look at an illustration of type 1 and type 2 errors next. So here we have identified the probability of making a type 1 error, and we are, remember, assuming the null hypothesis is true, and here I've said the mean time for cure is 42 days. And if we have a look down here at the probability of making a type 2 error, and in this case I have selected an alternative scenario where the mean for the new treatment is not very different from 42, and you can see there's a very high probability of making a type 2 error in that case. And in this case I've made the mean for the new treatment much less than the mean for the original treatment, and you can see there's a very low probability of making a type 2 error in that case. And that's the end of this video. The next video will look at type 1 and type 2 error examples.